Hi there. Let's look at how to find the least common multiple of some numbers that are given to you. Now this ties back to doing a prime factorization. So I'm going to look at like these three numbers. I got an 8, a 16, and a 14, and I'm trying to find the smallest number that is a multiple of all three of those. All right, so to look at that, I'm going to go back to what we did in a previous lesson where we had to find the prime factorization. So I'm going to look at 8, and I'm going to do the prime factorization on 8. And I kind of look at it like doing a factor tree, and I just say what multiplies to 8. Well, 8 can be 2 times 4. And since 2 is already prime, then I'm done with that, but 4 is not prime, so I'm going to break it down to 2 times 2. And now I've got it broken down to a 2, a 2, and a 2 are the prime factorizations, which means 2 times 2 times 2 would equal 8. I'm going to write that as a 2 to the third power. Now, let's try it again with each one of these numbers. So I'm going to come over here and I'm going to do 16, and I'm going to do the prime factorization for 16. And I would say, oh, that's 4 times 4. And you can do this different ways, but you should still end up down at the end with the same prime factorization. 4 is really just 2 times 2, and I can do it again, 2 times 2, and those are all prime factors. So I've got a 2 times a 2 times a 2 times a 2, which gets me 16. I'm going to write it as a 2 to the fourth power. All right, I've got to do it one more time. I got a 14. The prime factorization for 14, well, that'd be 2 times 7. Now 2 and 7 are both prime, so there's nothing else to do. The prime factorization is going to be 2 times 7. Now, that's what we've already done. Now let's look at what we need to do beyond that. To find the least common multiple, I'm going to look at these prime factorizations that I have here. And it would appear that I have, well, I've got this prime factorization and this one and this one. What I have to do is I have to pull out all the different prime factors that I see here. So it looks like the different prime factors would be a 2 and a 7. Those are the two that I have. So I know I'm going to be taking 2 times 7. But I want to be sure that I use as many of them as I need, as many 2s as I need, and as many 7s that I need, that would fulfill any of these individual prime factorizations. So just this 1 2 that I have here isn't enough, except for this one. This says I need a 2 to the fourth. This one says I need a 2 to the third. I'm always going to pick the one that has the most. So this right here, this 2 to the fourth, that's what I really need to put here, a 2 to the fourth power. And when I multiply that, well, 2 to the fourth happens to be 16, and 16 times 7 then is going to be my least common multiple. 16 times 7 would be, I think it's 128, or sorry, 112. That's what I get for that. And so that's the smallest number that all three of these will go into. That's going to be important later on when we start working more with fractions, is being able to find that least common multiple. Now let's try it again with an example where that gets a little crazier. They have here these three different things, and see it's separated by a comma. So it's this big mess, and this big mess. But if you pay attention to what the directions say, it says find the least common multiple of the numerical coefficients. So as messy as those all are, I'm really only looking at the numerical coefficients. So make sure on these problems that you read the directions on what you're supposed to find the least common multiple for. I'm just looking to find the least common multiple for a 6, an 8, and a 2. 6, as far as a prime factorization, is going to be a 2 times 3. 8 is going to be a 2 times a 4, but then that 4 becomes a 2 and a 2. So that's a 2 to the third power. And then this one is really just 2. Looks like then what I have is a 2 times 3, a 2 to the third power, and a 2. To do the least common multiple, I pick out all the different prime factors. So I see that I have a 2 and I have a 3, but I want to make sure that I use the highest power on any one of those. The 2 on this particular one is only to the first, but this one says it needs to be to the third. This is to the first, so the one with the highest would be this one. So I really want this to say 2 to the third power. As far as the 3's, I just have the 3 there. I don't have the 3 as a prime factor anywhere else, so it is fine as being to the first. So I'm going to change this to a 2 to the third power. Well, 2 to the third power is just 8, and 8 times 3 is 24. So 24 is the smallest number that 6 and 8 and 2 all go into. And that's, again, only looking at the numerical coefficients. If you come across a problem where you don't really have any numerical coefficients, on this one you can see that all the terms, this one, and this one, and this one, there's no coefficient on this. It's just all variable stuff. That's actually easier, because if I'm looking at the variable part of this, I'm looking at the a's. And this particular term needs an a to the third. This one needs an a to the third. This one needs an a squared. It's the same deal with the numbers. Apparently I need an a. But as far as how many a's I need, well, I pick the one that has the most. So it looks like it needs to be an a to the third. And then I'm going to do the b's. Let's look at each one of the b's. This one says b to the fourth, b to the fifth, b to the fourth. So I'm going to need a b, and I want to pick it to the highest power, so it looks like that second term was to the fifth. And then let's look at the c's. The first term is to the fourth, the next one's to the third, and then to the fourth. So the highest power would be to the fourth. And there's your least common multiple. Now sometimes they might tie that idea together. They'll have a number, so you have to work on the numbers like we did previously, and then they might do the variables also, in which case you have to do the variables like I just did there. Like this problem, for example. Look at the directions. It says find the least common multiple of the 3 terms. So I've got this, I got this, I get this. Let's start with the numbers. I need to find the number that 45, 9, and 10 will all go into. Let's come over here and we'll start our least common multiple process. 45. Do your prime factorization, so 5 times 9. 9 can be broken down to 3 times 3, but 5 is already prime. I've got a 5, a 3, and a 3. I'm going to write that as 5 times 3 squared. Now let's do it again with 9. 9 can be broken down to the prime factors 3 times 3. And then those are all prime. I'm done. So that's a 3 squared. And then I do 10. Break it down to the prime factors. That's 2 times 5. Those happen to both be prime, so I'm done with that. It's just a 2 times a 5. Now we come over here, and we're going to do each one of those factors. It looks like I need a 2. I'm going to need a 3, and I'm going to need a 5. But the 3 looks like it needs to be taken to the higher power of a 2. The others are fine the way they are. When I multiply those, that's a 2 times, this is 9 times 5. 2 times, well, and the order that you multiply doesn't matter, but I could do 2 times 5, that's 10 times the 9. Maybe that's easier to do in my head, but that's 90. However you do it, it's a 90. And then let's look at the variable part of it. If I look at the variables, I know I'm going to need an a. This is only there once. Oh, that one's to the 5th, and again to the 5th. That means I'm going to want an a to the 5th. Now let's do it with b. b is only to the first power. Remember, it's assumed to be the first if there's nothing there. Here it's to the 5th. Here it's again to the 1st. So I'm just going to want a b to the 5th for that one. And let me go ahead and talk about c to the 5th, to the 5th, to the 5th. b to the 5th, and c to the 5th. And that's the least common multiple of that when you're dealing with numbers and variables at the same time. This is our last example, and it's kind of like a little application of why you would ever need to know a least common multiple. And it says here that 2 cruise ships leave Tampa at the same time. They take 16 and 20 days respectively. That means like in the same order. So it's going to take the first cruise ship 16 hours and the second cruise ship 16 days, and then the second one takes 20 days to reach their destination and get back to Tampa. And then they take continuous trips, so that means they take off again and they go and for another 16-day long or 20-day long trip. If they both leave at a particular day, when's the next time they're going to leave on the same day? If you think about it, here's what's going on. The first cruise ship leaves and takes 16 days, whereas the second one leaves and takes 20 days. But then this one's going to pick up again and take off and only go for 16 days, whereas this one's going to take off again and go for 20 days. And then you can see that they're going to get farther and farther off, but at some point, it's going to meet back up. Well, that some point is going to happen at the least common multiple of these two numbers, of 16 and 20. All right, so let's just find the least common multiple of 16 and 20. That's all you're really doing here. So 16, if I do the prime factorization, that's 4 times 4, which breaks down to 2 and 2, and another 2 and 2. That leaves me with a 2 to the 4th. When I do 20, that's a 4 and a 5, which breaks down to 2 and 2 and 5. That's going to have a prime factorization of 2 squared times 5, which means as far as the least common multiple, I'm going to need a 2 to its highest power that I see, which means to the 4th, times 5. Well, 2 to the 4th, if you think about where it came from, it just came from this number right here. There's 2 to the 4th, that's 16, and 16 times 5 is 80. So in 80 days, the 2 ships are going to be taking off at the same time again. It just means that the one that doesn't take as long will have had more trips by that time. All right, that's all I've got for you. Hope this video helps.